Alright, moving right along here, looking at number 7. This question's asking you to find the zeros of that given function, and then after you've stated the zeros, they want you to graph the function. It's very nice that they already gave us a function that is already factored, and when it's already factored, we can use the zero product property. Remember how that zero product property works. If I'm trying to find zeros, and I have a zero, say, I don't know, right here, I'm trying to figure out, hey, when is this function going to be 0? That means this guy times that guy needs to be equal to 0. So what must be true? One of these three factors needs to be 0. Since we don't know which one, we set each one up individually and solve for each one. So wouldn't this be a true statement about our zeros? Our zeros, if you can barely see it, there we go. Those should be our solutions, right? One answer should be 0, because if that first x was 0, 0, 0, 0, multiply, we'd get 0 for an answer. 5, if we put a 5, a 5, a 5 there, the middle term would give us a 0, and we'd end up with a product of 0. And if we put a 4, a 4, and a 4 right there, the last term would make that a 0, and boom, we'd have 0 for an answer right there. So those would be part 1, answering that question, identifying all of those zeros, which is what we did. Now the next part is graphing the function. You know what I would do? Wow, this seems like pretty much a no-brainer to me, is I would just take that graph that's right, or that function that's already there, and just type it into my graphing calculator. To have x parentheses, and then x minus 5, and then another parenthesis, and we'd have x minus 4. Type that in, hit graph, and you've got a nice little graph of that situation right there, which I'll put right there for us. Notice how that graph went up, it curved, comes back down, and hits those spots right there. So, in order for you to get full credit on this here, I want you to plot these points. And if we go to the table here, in order for you to get full credit, there are those zeros. I want to see those. And you can see that up based on the table where those zeros are, or we can look at it from our answer. But for you to get full credit on this question, and this is where a lot of people in the accelerated algebra class were missing some points. They were doing the zero parts just fine. See those 3 dots right there? The problem is after that, I ended up taking points off, because from here they were looking at this picture, and then they were just going wee and just trying to just make a pretty lazy sketch of the whole thing. Okay? You are not allowed to do that. Not only do I want you to plot all the zeros, which is what we did, you need to plot all the points in between the zeros. What does that mean? Here's what it means. Okay? See this table of values right there? You have a lowest 0. You need to plot all these points that are in between. See how these go from 0 to 12 in this little window right here? Or better yet, it goes from, say, 0 to 0 right here, from 0 to 5. That means this little tight little window right here, I need to see some ordered pairs plotted. There are some missing ordered pairs. There are missing inputs here. For example, I have 0, 0 taken care of right here with that first dot. And then the next time I put a dot doesn't happen until I get to 4, 0. But what about all these points here in between? We need to plot those points. So if you want full credit on this test, you need to plot all of those points in between. So at one point we need to point at 1, 12. Put that point right there. See it? 1, 12, since this graph is counting by 4s, going vertically. I need another spot at 2, 12. So there's another one right there. And then we need one at 3, 6. There we go. And I think that about does it, right? Because now we have enough points there. And the only reason why I put a point right there is because, quite honestly, it fit in the graph, 6, 12. 6, 12 fits. And then we can make that curve. Okay? So if you want full credit for this problem, make sure that you plot all those points that are in between the lowest 0 and the highest 0. Alright, so looking at number 8. Let's write a cubic polynomial function that has zeros of 2, -4, and 3. So on these problems, here's what you're starting off with. If we're telling you have zeros of 2, -4, and 3, it's like trying to solve a polynomial and we're telling you right away, hey, an answer, x equals 2. And then another answer, x equals -4. And then another answer, x would be equal to 3. And so what your job was on those problems is to write to linear factors that went with it. And the linear factors that would give us those as answers, and we use the zero product property would have to look something like this, right? X minus 2 would give us an answer of 2, right? If we set it equal to 0. And then the x plus 4 would work for if we have a 0 of -4. And then if we have a 0 of 3, x minus 3 would be that linear factor. And so then what we'd have to do next is multiply a pair together. Doesn't matter what pair, I just multiply these two together. How about we just multiply those? Okay? And so then when you multiply those, first, outer, inner, last, x times x, distributive property there, would give us x squared. X times the 4 would give us the 4x. -2 times x, and -2 times a positive 4 would give us a -8, right? So we'd have that, still times the x minus 3, but oh look, we have like terms right here of a positive 4 and a -2x, positive 4x and a -2x. Combine those together, and we should get something that looks a lot like this with a positive 2x there minus the 8, and then x minus 3. But we're not done yet. We have to multiply those together. So to multiply those together, there are many different formats. You can do distributive property just like we did before. A lot of you are kind of fans of this type of matrix type of a array, rectangular array of multiplying these together. Okay? Key thing to remember is that when you're filling in the spaces, remember it's multiplication. So when we're multiplying and filling in that first space, please remember you're taking x squared and not times just any old x to nothing but x to the first power, just like this is an x to the first power. So make sure you're thinking about that when you're multiplying those together and the exponents do add together, right? So we should have here x to the third. We multiply those together, and that should give us 2x squared. A -8. The biggest problem that happens here with students is they forget to put the negative signs in there when they're filling in the boxes. Or they forget another key feature here, not only forgetting to put the negatives and forgetting exponents when exponents should be there, it's this right here. See that -3 times a -8? A lot of students forget that that's a positive 24. I'll even write the plus 24 right there. And so then what are we hunting for now? We are now hunting for like terms. And if you notice, we have like terms here. So we can combine those together. Remember, combine with addition with algebra means add those together. So when we write our final answer, we should have x to the third as our first term. Our second term, our quadratic term, should be -3 plus x squared plus 2x squared, should be -1x squared. And then we combine those two negatives together through addition, we should get -14x, and then last but not least, that positive 24. Okay? So you will have a problem just like that on this test. Okay? Nice little hint here, that one's going to be multiple choice. And just wink, wink, nudge, nudge, if you're actually watching these videos, if it was multiple choice, couldn't you take, I don't know, the 4 answer choices that would have the functions there and look for the ones that could have that as the zeros? I don't know. Maybe that might be a way to work the problem backwards with a graphing calculator. Couldn't hurt. Alright, and let's finish up this part of the review by just looking at question number 9. What are the zeros of this function? Well, one thing that jumps out at me right away, it's a quartic function. But not only that, I can see some greatest common factors here. I think there is a greatest common factor. Can you see it? Well, it wouldn't be anything with the numbers because there's leading coefficients of 1. But if you look at the x's, the variables, x to the fourth, x to the third, x to the second power, I'm pretty sure we do have a greatest common factor of x squared. So we can factor out that x squared. Okay, if we factor out x squared, that's going to leave us x squared minus 8x plus 16. You know you factored it properly when you do the distributive property here to check it and see if you get that back up there in black. Okay, it looks pretty good, right? X squared times x squared is x to the fourth. X squared times a -8x would be -8x cubed or minus 8x cubed. And then x squared times a positive 16 would give us positive 16x squared. Since we're looking for zeros, I'm going to set it equal to 0. Why do I have that highlighted there in blue? Because I think we can factor that. I can come up with two numbers whose product is positive 16 and their sum is negative 8. I think that would have to be two negative 4s. Okay? And then we know how our zero product property works. Can't we set those all equal to 0? Since the minus 4s are duplicates, we only really need to write it down once. And then to solve this one here in red, what do we need to do to both sides? Boy, that equal sign is really, really crooked. There we go, a little bit better. And then to solve that one, couldn't we then take the square root of both sides? But I think you guys know what the square root of 0 is. I think that's going to be 0. How would I solve this problem over here? Wouldn't I just need to add 4 to both sides? And so that would lead me to a correct answer here of 0 and 4. What's awesome about this problem is that we just got 4 as an answer twice. Actually, we got 4 as an answer twice, and we got 0 as an answer twice. Here's one thing that I highly recommend you do anytime you have a a function problem like this and they're asking you for the zeros. Definitely take some time and check your answer with the graphing calculator. Look what happens if I check my answer with the graphing calculator. First thing I would do is type it into the graphing calculator, get it graphed, and I would see this curve would do something like this. And see those two dots? Those two dots right there are indicating the zeros of that function. Okay? Notice that the graph bounces and touches at 0 and 4. So what that kind of implies is that we have 0 at 0, which occurred twice, and a 0 at 4, which occurred twice. Okay? So that's how number 9 works. I would recommend you could either do GCF work, or you could probably even start this problem with the graphing calculator, and I wonder if that might even lead to some correct answers right away. Alright, so we'll end this part of the review and we'll move on to another part, starting with question number 10.